Hi students, welcome to the science class. In today's session, under the chapter of force and pressure, we are going to discuss the sum of the activities or the sum of the concepts which we are going to use the force and the pressure. So in this lesson we are going to study what is the force, what are the characteristics of the force, what are the changes that will be seen due to the force, and also what is meant by the pressure and what are the properties of that pressure that will be studied in this session. So imagine that you are pulling a door of your room, or imagine that you are bowling, or imagine that you are playing in a ground, that is a cricket, you are hitting a ball, isn't it? Next, again you can imagine another one important thing here, just you are pushing on a stool or on a table. What happens here? So when you are going to when you are going to make a bowling, the ball will be moved, isn't it? You are going to apply the force on it, isn't it? So there is a change in the position of the object. So again one example I am taking here. When you are going to push a table, before you are going to push the table is at the rest position. I am taking, if you are going to push a table, if it is at the position A, if the table is present at the position A, when you are going to apply or when you are going to push the table, it changes its position to B here, isn't it? So when you are going to push a ball, it also travels a somewhat distance. So imagine that you are playing a football, when the football is present, or you cannot get a imagine that you can get a penalty kick. So when you are going to use the penalty kick, the ball will be landed, or ball will be present in the rest position. When you are going to kick the ball, it moves from that position towards the goal, isn't it? There is a change in the position, but why that change in the position occurs here? Why the door, when you are going to pull the door, why the door will be opened? Why the position of the door will be changes here? When you are going to push the table, there is a change in the position. Why it is changes its position? Because due to the force. So in a science, we are going to say a push or a pull on an object, it is called it as a force. So change in the position of an object, it is due to the force applied by on it. So what is meant by the force here? The force, it is nothing but push or pull on an object is called it as a force. Push or a pull. For example, you are going to push the table, due to the force you are going to apply some force here, isn't it? Your muscle force. And when you are going to pull a dryer, there is also change in the position of the object, so it is also due to the force. So in your examination, 1 marks question will be asked on this. What is meant by the force? The force, it is nothing but a push or pull on an object, it is called it as a force. A push or a pull. You are pushing a ball. Imagine that you are playing a volleyball, just you are pushing the ball, isn't it? That is also due to the force here. And what are the changes when we are going to see if we are going to apply the force? When you are going to apply the force, there is a changes on the body here. One example I am taking, when you are going to apply some force on any body, first changes you are going to observe here is change in the position of the object, isn't it? For example, if the table is present here, imagine that a table is present here. If I am not pushing it, or if I am not applying any force on it, it doesn't move, it will be stay in their original position. But when you are going to apply some force on the table, it moves towards that side, somewhat distance. That distance is due to the force. So force will bring change in the position of the object. The force will bring change in the position of the object. So when the force will only brings the change in the position of the object, imagine that. So the same table you are going to imagine here. I am considering one table here, this is one table. So imagine that your two friends are going to push the table here. A person will be stand here, his name was A, and another one student or another one your friend will be stand here, his name was B. Imagine that he is also try to push the table in this direction, and he is also try to push the direction in this direction. Imagine they have a equal amount of energy, they are equal in size. So what happened, even though we are going to say when the force will be acted on a body, it will be changes its position or it acts on the motion of the body, but when both the students or both your friends applying force on a table, there is no change in the position of the table here. Why? Because here these are all the equal forces are a balanced force. So we are going to see here a balanced force. The force exerted by the A will be equal to the force exerted by the B, but both A and B, both the forces of A and B will be in the opposite direction. Therefore, they are get balanced. There is no change in the position of the object. The position of the object will be changed due to the force if and only if there is an unbalanced force is present. Is it clear? For example, if here two students are present, then the amount of the force exerted by the two students is greater than the amount of the force exerted by the one student. Then this is unbalanced force. Then the table will be moves in this direction, isn't it? Because here two persons are there and that side only one person is there. He was also pulling and both these are also pulling, but comparatively the energy produced by the two persons is greater than the one person. Therefore, there is a change in the position of the object. Therefore, in that condition we can see in the movement of the object. So you have to remember this is an unbalanced force. If imagine in that side also two persons are present and this side also two persons are present, the table will not move here. Why? Because the forces are balanced. Therefore, that forces are called as a balanced forces, and the forces in a first situation, that is in one side two persons are present, in another one side one person is present, they are trying to push the table. There is a change in the position of the table. In this condition we are going to call it as a unbalanced force. You have to remember, we are going to see only when an unbalanced force will be act on object, then that condition we are going to see there is a change in the position of the object. If the force exerted by the body is a balanced force, then there is no change in the position of the object. So that's are known as a balanced and unbalanced force here. Is it clear? I am taking another one example here. The one of the game will be played in your earlier days, that is with the help of the rope, isn't it? The pulling of the rope by the two teams. As the members of the teams decreases, that team will comes towards the line, isn't it? Due to the increase in the force by the another one team, isn't it? That is another one example for the balanced and unbalanced force. So another one example I am taking here. If you are going to apply the force on the wall, wall will be moves here? No, wall doesn't move here. Why? Because the opposite force exerted by the wall, it is greater than the force applied by you, isn't it? For example, imagine that the wall will be and a bulldozer applies the force to the wall. Is there change in the position of the wall? As we can see, the wall will be broken down, and the stones are blocks which are present in the walls will be moved away from the wall, isn't it? Why? Because the force applied by the bulldozer to the wall, it is greater than the force exerted by the wall towards the bulldozer. But when you are going to push the wall, there is no change in the position of the wall. Why? Because the force exerted by the wall towards you, it is greater than your force, isn't it? That's why there is no change in the position of the wall here. So when we are going to see a change in the position of the object when there is a unbalanced force is present. Is it clear? So under one thing, the force brings change in the shape of the object. The force brings change in the position of the object. Take a plastic bottle and apply some force on it or hit on it. Due to the muscles action, you are going to apply some force on the bottle, water bottle, plastic bottle. You are going to see the motion of there is a change in the position of the object and also the change in the shape of the object. It is somewhat crushed at the part where you are going to apply the force, isn't it? So the force brings the change in the shape of the object, isn't it? And again I am under an example taking here. Take a plastic ball, place it on a roof or place it on a land and apply some force on it with the help of the stick. What happens? It doesn't move, but some part of the plastic ball will be, what happen here? The shape of the plastic ball will be somewhat changes here due to the force. So force can bring change in the shape of the object. And next one, it is force may make an object move from the rest. Again I am taking another one example. If we are going to apply the force to a rest body, that rest body can take the movement here due to the force. Again I am one of the example I am taking here. The force acting on the body, it can changes the moment of the object and also speed of the object. You have to remember here. For example, you are going to imagine that you are rolling a ball. At somewhat distance, again you can apply some pressure in the backward direction, in the same direction. You are going to see somewhat speed, you are going to see somewhat change in the speed of the ball here, isn't it? Again I am explaining here. Take a ball, roll it and it covers some distance, and again you go there when it is moving and again apply some pressure on it or some force on it. So what happen? Again it changes its direction, again the speed of the ball will be changes here. But again take that same ball, roll it, and in second case you have to apply the force in the opposite direction. Imagine that the ball will be rolling in this direction, you will apply the force in this direction. What happens? The speed of the ball will be decreases here, isn't it? So the force exerted by the force will be exerts, and the force which exerts on a body that can change, that can alter the speed of a body. You have to remember, if the force applied on a body, if it is present in the direction of the motion of the object, then it increases the speed of the object. If the force which is present or which will be applied in the direction of the moving object, then the speed of the object will be increases. If the force will applied to the opposite direction to the moving body, that decreases the speed of the object here. So it is under one condition of the force. And the force may change the direction of the object. Again another one example here. The force can bring the change in the direction of the object. For example, roll a ball very fastly, suddenly you can put a bat or suddenly you can put a bat opposite to the ball. What happens? The ball will be runs in this direction. When you are going to put the bat in opposite to the direction of the motion of the ball, it can changes the direction of the ball either this way or this way, isn't it? For example, imagine that a batsman hitting a ball, the ball will be comes in this direction, isn't it? But when the batsman applies the force on the ball will be goes opposite to that direction, or in which direction the batsman want, in that direction the ball will be goes. So why it is goes? Due to the applied by the force, isn't it? When the force acting on a body, it can changes the direction, isn't it? So it is under one condition of the force here. Force can change the direction of the motion of an object. and it may change the shape of the object. As I told already, the force can bring a change in the structure or the change in the shape of an object. So these are all are the properties of the forces here. What are the properties of the forces? Force is present due to the interaction between the two objects. We have to remember here, the force is only present or the force is only acting due to the interaction between minimum two objects, isn't it? For example, I am taking one example here. If a car is present before you, or a car is present, it is not traveling. If you are going to push the car, it will take some distances, isn't it? It will take some of the movement here. If you are not pushing the car, you are standing behind the car, is there any change in the motion of the car? Is there any change in the position of the car? So when you are going to interact with the object, then only the force will be acting here. If you are not interact with the other object, we can't see any force in that. So the force is present due to the interaction between the two objects, you have to remember. And another one, it is the balanced and the unbalanced force. The two types of the main important two types of the force which we are going to see, the balanced force and unbalanced force. What is the balanced force? If the force acting on a body doesn't changes its position, or if the force acting on a body, some of the forces acting on a body that doesn't changes the position of the body or doesn't affects the shape of the body, then that type of the forces are called as a balanced forces. If the forces applied on a body can alter the position of the object, can alter the motion of the object, then that forces are called as a unbalanced forces. And the force can make an object move from the rest. And under one property here, the force may affect on the speed of the object. Yes, as I told already, if the force will be applied in the direction of the motion of the object, that may increases the speed of the object, isn't it? If you are, imagine that you are rolling a wheel of a bicycle, if you are going to apply the force in the direction where the wheel of the bicycle will be running, then the speed of the wheel will be increases, isn't it? Imagine that you are rolling a wheel of a bicycle. If you are applying the pressure in the direction of the rolling wheel, then the speed of the wheel will be increases. If you are applying the pressure opposite to the rolling of the bicycle wheel or a bike wheel, then the speed of the wheel will be decreases. It may affect, it may alter, the force may alter speed of the object, and it may change the direction of the object, and force may change the shape of the object. These are all properties of the force here. And we are going to see different types of the forces in nature. There are some different types of the forces are present in the nature. In this session, we are going to study two types of the force, that are contact forces and under one it is a non-contact forces. The contact forces, the word itself says the pressure due to the contact between the two objects, that are called as a contact forces. In the contact forces, we are going to see first one, it is a muscular force, second one it is a frictional force. The muscular force, it is nothing but the word itself says the force acted by the action of the muscles. For example, I am writing here, I am applying some of the force on the chalk piece to write some of the explanation here. So for to write I am applying some force, that force will becomes from the muscles of my body, then that force it is called as a muscular force. Why muscular force? It will be comes under the contact forces. I am connected with the pencil here, I am connected with the board here. So imagine that you are kicking a ball, you are hitting a ball towards a 6 in a cricket, isn't it? These are all the contact forces. Why? Because these are all contact forces. It is due to the motion of our muscles, the force which is produced by the action of the muscles, that force it is called as a muscular force. It is one type of the contact force here. And the second type of the contact force, it is nothing but the frictional force. So what is frictional force? Imagine here, now take a ball and roll it with some speed, or you have to throw it with some speed. You have to observe clearly here, after some time the ball will be comes to rest, isn't it? The ball will becomes to rest. And why it is comes to rest? The force will be acting on it. It can be moved continuously, but why it is comes to rest? Because the ball can experience the opposite force by the land here, isn't it? The ball can experience some of the opposite force by the land, isn't it? And also imagine that you are sliding a table on a tiles. Remember, you are sliding a table on a tiles. Is it very easy to slide a table on a tiles? But imagine if you are going to try to slide a table on the land. Is it very easy to slide a table on the land? No, it is very difficult, because we are experiencing an opposite force by the object that is called as a land here. So that force, it is nothing but the frictional force. So what is the frictional force? The frictional force, it is nothing but the opposite force experienced by the moving body. The opposite force experienced by the moving body, that is known as the frictional force. So you have to remember here, we are walking due to the walking will be done with the help of the frictional force here. If there is no frictional force is present, so it is very difficult to walk for us. So you have to remember, the frictional force plays a very important role here. Under one example I am taking, when the running bicycle or a running wheel, if you are not going to continue to apply the force on a running wheel, it will becomes rest at one end. Why it will becomes rest at one end? Because it experiences some opposite force from the land, that is nothing but the frictional force. The frictional force, it is nothing but a force exerted by a body due to the sliding on it. For example, you are sliding a table on a land. It is very difficult to slide a table. Why? Because the opposite force will be exerted by the land. Therefore that force, it is called it as a frictional force, and that frictional force, it is comes under the contact forces. And these are main two important types of the contact force. Again I am taking here the second type of the forces, that are nothing but non-contact forces. These are the contact forces, that is, these forces are produced due to the interaction between the two objects. We are going to see the force which is produced by the interaction between the two objects. But in our nature, we are going to see there is a change in the position of the object, even though there is no contact between the two objects, and such a type of the forces are called as a non-contact forces. For example, imagine that you are holding two magnets here. You are holding two magnets. You are holding two bar magnets, NS, and another one it is NS. If you are going to connect, or if you are going to bring the same poles of the magnet at each other, if you are going to bring same poles of the magnet to each other, what happens? There is a push or there is a pull in the magnet. So push or pull in the any object, that will be called it as a force. So but there is no contact here. So when you are going to bring same poles of the magnet to each other, so what happens here? The magnets will be repelled, isn't it? The magnets will be repelled here. So we are going to see the change in the position of the object here, isn't it? For example, place a bar magnet on 3 to 4 pencils. Placed on a bar magnet, 3 to 4 pencils are on a pen, and bring another one magnet, bring the side of the same pole of another one magnet. For example, this is the north pole, this is the south pole. Take another one magnet and bring a same pole, that is south here. Now north pole is there, bring a north pole of another magnet. What happens here? The magnet will be pulled backwards, isn't it? It will be repelled backwards. So there is a change in the position of the object. So where there is a change in the position of the object, there will be force is acting on it, and that shows the force will be present here. But there is no contact in the two objects here, there is no contacts in the two magnets here. So we can see the non-contact force here. So one of the example for the non-contact force, it is nothing but the magnetic force. The force due to the the force produced by the magnet, it is called it as a non-contact force. And another one non-contact force which we are going to see, that is nothing but the electrostatic force. Take a pen and rub to your head. Take a pen and rub to your head and bring that pen towards at one end of the paper of your textbook or a notebook. You have to clearly observe here, the paper will be get attracted by the pen, and that we can see there is a change in the position of the paper here, isn't it? So why it will be get attracted? Because it will be get attracted due to the electrostatic particles which are present in that will be attract the paper which is present here. So the force which is exerted by the electrostatic particles, that is also non-contact force here, because you are not going to contact the pen to the paper, but also the paper will be get attracted by the pen. You can check it with your comb also. If you are going to use the comb or take a comb and rub it to your head, bring that comb towards any paper. So the paper will be get attracted by the comb, but there is no contact here. So the force will be exerted by the comb on the paper. So such type of the force, it is called it as a non-contact force. Because why this force will be acted here? Due to the electrostatic particles. When you are going to rub the comb towards your head, some of the electrostatic particles which are present in our head get attached to the comb, and that attracts the paper here. So the electrostatic force, it is another one example for the non-contact forces. And third one, it is a gravitational force. So just try to throw a ball towards sky. What happens? The ball will be comes again to the land here. The ball again they can be get attracted by the land here. There is also change in the position of the object. You are applying the force to the ball to go towards the sky here, but at a somewhat distance, after covering a somewhat distance, the ball will be again comes back to the earth. Why? Because that can be get attracted by the force of the earth. That force, it is nothing but the gravitational force. The gravitational force, it is not only present in the earth, but gravitational force, it will be present in all moving bodies. So here also there is no contact. When you are going to throw the ball, the earth will be contact with the ball? No, there is no contact with the ball, but also there is change in the position of the object. So it is another one type of the non-contact force, that is nothing but the gravitational force. So this is all about what is meant by the force and some of the types of the force, that are contact forces and the non-contact forces. So I am taking one example here. Take a pin or take a nail. Try to push a nail with its head. Imagine that the nail is just like this, isn't it? The nail is just like this. Try to push the nail with its head towards a sheet of a wood or towards a wood sheet. Is it possible to push the nail with its head towards the sheet? It is very difficult to push that nail towards the wooden sheet. But reverse the head here. You can take the sharp end of the needle and try to pull the nail towards the sheet. It is very easily passes through the wooden sheet. Why it is very easily passes through the wooden sheet? Because when you are going to apply the force on the nail, the area which is present at the head, it is very large, and the force applied by you, it will be not sufficient to move towards into the move into the sheet here, but when you are going to apply the force towards head, from the head towards the another end of the nail, the nail will be very easily passes through the wooden sheet. Why? Because due to the pressure. So what is meant by the pressure here? Pressure, it is nothing but the force acting on a unit surface. It is called it as a pressure. The force acting on a unit surface, you are going to apply the force at the one end, but that all forces will be that concentrated at the another one small end, isn't it? You are applying large amount of the force. If you are applying large amount of the force at the head of the nail, and that force will be concentrated, all the force will be concentrated at the single point here. When all the force will be concentrated at the single point, the amount of the force will be increases, and that can be easily we can push nail into the wooden sheet here. So that it is nothing but the pressure here. What is meant by the pressure? Pressure, it is nothing but the force acting on a unit surface. It is called it as a pressure. If you are considering a nail, if you are going to apply the force on it, all the force will be concentrated at the sharp end of the nail, and that can be easily the nail will be goes into the wooden sheet. So this force, it is called this force, it is due to the pressure here, and that pressure, it is nothing but the force acting on a unit surface. That is called it as a pressure. All the force will be acted on it unit surface, therefore this is called it as a pressure. The pressure is equal to, we can write it as an expression, pressure is equal to force divided by area on which it acts. So increase in the area, decrease in the pressure. Is it clear? If you are going to increase the point of the nail here, there is a decrease in the pressure. If you are decreasing the surface area, then there is increase in the pressure. So pressure is equal to force divided by area on which it acts. And the pressure, it is also exerted by the water. For example, I am taking one example here. Take a cylinder. Take a cylinder hollow cylinder. At one end you have to fix a balloon. At one end you have to fix a balloon. Now you have to pour some water into that cylinder. What happened here? You are going to see there is a bulb will be formed. There is a bulb will be formed due to the water present in the cylinder. So what happens? Why the bulb will be formed here? Because the water which you are going to pour inside the cylinder, that exerts the pressure on the wall of the balloon here. Therefore the bulb will be formed. Another one example I am taking. Take a plastic bottle. Take a plastic bottle. Take a plastic bottle and make 4 holes. Make 4 holes on the bottom of the bottle. You have to make 4 holes here, and now you have to pour some water into the bottle. What happens here? You are going to see the water will becomes through all the 4 holes here. Why the water will becomes through all 4 holes? Because the water will exerts on the holes that will be present on the walls of the bottle here. So what it says here, water exerts the pressure on the wall of the container. So water will exerts the pressure on the wall of the container. So therefore the balloon will be, what happens here? The bulb will be formed due to the pressure exerted by the water. Here we are going to see the water will be forcefully come out from the bottle due to the pressure exerted by the water. In a similar fashion, the air, the gases also exerts the pressure here. When you are going to blow the balloon, the size of the balloon will be increases due to the pressure exerted by the air on the wall of the balloon, isn't it? So the pressure exerts the water exerts a pressure on the wall of the container, and the gases are also exerts the pressure on the wall of the container. So another one important thing which I am going to discuss here, that is nothing but the atmospheric pressure. So what is atmospheric pressure? As we know already, our atmosphere, it is covered with some amount of the air, that the amount of the air which is covered by the earth's surface, that is called it as a atmosphere. But we are going to feel some of the pressure due to that air which is present in the atmosphere, and that pressure, it is called it as a atmospheric pressure. For example, a rubber sucker, you are going to see a rubber sucker that will be present in some of the guns, toy guns. A rubber sucker, this is just like this, a rubber sucker. If you are going to apply the rubber sucker, some pressure on the rubber sucker towards the soft surface, it will be get attached to the surface here, isn't it? And you can easily pull it away by applying some force, isn't it? But if there is why it is very easy to pull away that rubber sucker, or why it is very take off the rubber sucker, because when you are going to push the rubber sucker towards the plane surface, some of the air particles which will be present in the rubber sucker will be present in between the surface and the rubber sucker, and that air exerts some pressure on the mouth of the rubber sucker, and then it is very easy to take it off. But if there is no air is present inside the rubber sucker, it is very harder to separate that rubber sucker from the surface, isn't it? So the pressure exerted by that air which is present inside the rubber sucker, that is nothing but the atmospheric pressure. What is atmospheric pressure? A pressure exerted by the atmospheric air, it is called it as a atmospheric pressure. So the atmospheric pressure can be balanced our body. The atmospheric pressure can balance some of the bodies which are present in the nature. So it is also another one important type of the pressure which we can see in our nature, that is nothing but the atmospheric pressure. So in this chapter we studied about what is meant by the force, what is meant by the pressure, what are the types of the forces, and what is meant by the atmospheric pressure. And this completes your another one chapter, force and pressure. In next session we are going to see our next lesson. Thank you.